Hi, boys and girls. Miss Gallagher and what's your name? Lorelai here. Today we are going to focus on fractions. However, I'm going to introduce how to solve dividing fractions using visuals and an equation. Okay, so that's what we'll work on today. Just some new content. Go from there. So as I've mentioned before, fractions is really just division. And I wanted to go over a couple things before we dive into dividing fractions. Okay. If I have the fraction 4/12, this is the same. This is the same as 12 divided by 4. Okay. This, our numerator, is always going to be our dividend. Say dividend. Our numerator is always going to be our divisor. And as you can see, divisor is always there. Our dividend is always inside. Dividend inside our division symbol. So a way for me to remember, and I always tell you guys weird little things that help me to remember certain things. Hold on, sweetie. You can sit right here. Okay. If I'm looking at the word dividend and divisor, the only difference we get over here to the D and the S, dividend is always going to be on the top, divisor is going to be on the bottom, D comes before S. So that's how I always remember that the dividend is always the numerator and the divisor is always the denominator. And then, likewise, dividend, I remember that it's always inside because I hear the in dividend, even though there's not the real word in. Divisor is on the outside. Okay, I wanted to go over that because we will need to know this. And I'm going to solve a division problem. And I want you to see how we get our answer in a division problem, how that converts into a fraction. It's pretty cool. Okay. So I'm going to start with 3 divided by 17, okay? So if I have 17 objects, I want to make them into 3 groups. Obviously, she's fine, right? Okay. So the quotient is going to give us how many we put in each of those groups. So we have 17 of something, or we're putting them into 3 groups. Our quotient's going to tell us how many are going to be in each group. Okay, so Lorelai, we cannot erase that right now. Can you sit right here?
Yeah.
Okay, thank you. You can help me in a second. All right, so looking at our digit, we have 1 and 1. Does 3 go into 1? No, so we have to look at our next digit. It goes into 17. Does 3 go into 17? Yes, it does. It goes in 5 times. Can you say 5? 5 times. So I'm going to write a 5. 3 times 5 is 15. So I'm going to subtract 15. Okay, so now I have 17 minus 15. 7 minus 5 is going to be 2. Sorry. And then 1 minus 1 is 0. So that's all I have. I don't have any more numbers in my dividend. So this is going to be a remainder 2. Now let me show you. That does not look like an R. Let me show you how this is going to convert, how my quotient converts into a fraction. Okay? Look at it this way. Our divisor, if you remember from a few minutes ago, our divisor is always going to be our S is on the bottom, comes after D, so it's going to be our denominator. So I'm going to have this equal here. That's going to be my denominator. How many whole times does 3 go into 17? 5 whole times. So that's my whole number. And how much is remaining? 2. So 3 divided by 17 as a fraction is going to equal 5 2/3. So we have 5 wholes and a remainder of 2. This, let's get another marker. Divisor is denominator. Our whole number, whatever our whole number is going to be a whole number. And our remainder is going to be our numerator. Okay? Whew, that's a lot of stuff going on. Divisor is also your denominator. Your quotient is going to be part of your fraction. You're not doing anything with the dividend as far as the fraction goes, okay? Our whole number here, anything that is remaining is going to be our numerator. Let me erase this and then we'll do another one. Okay. Just nice and calm. Let's do 5 divided by 8. 8? Yeah. All right. Yeah, it's only a single digit division problem, but that's fine. 5 goes into 8 how many times? 1 whole time. So I'm going to subtract 5. 8 minus 5 is 3. 5 does not go into 3, so that's going to be my remainder. Okay? Now, do you remember? My divisor is my denominator. My whole number is my whole number. My remainder, my remainder is my numerator. So the fraction for this is going to be 1 whole and 3/5. Okay? Hopefully that's starting to make sense. Again, it's going to take a lot of practice to really get to remember what number goes where. But I just wanted to give you some sort of idea of what we're looking at in terms of dividing fractions and what that looks like. Okay. So this leads us to our next thing. What is division? Okay. Division is dividing into groups of a specific size. So division is thank you. Don't pull my hair, please. Into groups of a specific size.
I don't know.
Thank you, sweetheart. So if I write down an equation, I'm going to focus on a visual first of how to solve these problems. So if I have 4 divided by 1/5. Let's look at this, okay? This is a whole number, okay? So I have 4 wholes, and I want to divide it into what? Into 1/5. So what that's going to look like is I guess I'll make 4 holes. Here are my 4 holes. 1, 2, wow, they get smaller, I'm sorry. I have 4 holes, and I'm dividing it into 1/5. So, let's make this into fifths. Okay, so now I broke up each hole into 1/5, because it's saying if I have 4 holes and I divide them into 1/5, here's 1/5, 1/5, 1/5, 1/5. Now, how many 1/5s do I have? Let's do this. 1/5, 1/5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 1/5s. So 4 divided by 1/5 is 20. This is the visual way that I'm showing you first. So I'm going to do that with a few of the samples before I show you how to work the equation. So let's do our next one. I hope that makes sense. But we're going to do a few. We will do a few. My next one is going to be, let's do 3 divided by 1/2. Okay? So I'm going to have how many holes? 3 holes. 1, 2, 3. Each of my holes is going to be a half. Half, half, half. I'm going to label so we are clear. 1/2, 1/2. How many halves do I have now? 1, 2, 3, 4, 5, 6. Okay. Now we'll do another one. Let's say we have 6 divided by 1/3. How many holes am I going to have? 6. And how am I going to partition those 6? I'm going to partition them into thirds because I'm dividing it into thirds. So, and, okay, let me see. If you don't want to do the bars, I just find those the easiest. We can do little pies. 1, 2, 3, 4, 5, 6, and I do it into thirds. And I'll label it so we remember how much each one is worth. 1/3, 1/3, 1/3. How many thirds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? And obviously, you can count by threes. You don't have to count it one by one. I just really want you to get the idea of what that looks like. So, as you notice, I am dividing with whole numbers. I'm only doing that with whole numbers right now because I don't want to confuse you quite yet. Okay? Baby steps. This is something new. I haven't taught dividing fractions, so we are barely getting our feet wet with dividing fractions, and I'm going to do it with whole numbers first before I throw another fraction in here for you. Okay, so I made a little graph here. I'm going to write our problem. We're going to quickly do our visual, and then I'm going to show you how to do it in our equation, okay? That way you understand how it's working. Okay, so our first equation that we worked with was 4 divided by 1/5. Okay, we had our visual of 4 partitioned into fifths, right? 1, 2, 3, 4. Okay, and we knew that that was 20 fifths. There's 20 fifths here. Now our equation, what we're going to do here we go, get ready. I'll keep this. We are going to make our 4 into an improper fraction. And how do we do that? We put it over 1. So I'm going to put 4 over 1. Okay. Watch what I'm going to do. Divided by 1/5. However, we need to change this, and I'm going to throw a new word into our vocabulary, but it's going to be called a reciprocal. Reciprocal is your flip-flopping, okay? So 4 over 1 is going to stay the same. Then our division problem is going to turn into a multiplication symbol, and then 1/5, the reciprocal of 1/5 is 5 over 1. So we have to flip-flop. So flip, which is the reciprocal. Reciprocal, yes. Okay. Now you can multiply across, and we remember our multiplication rules. Multiply your numerators and then your denominators. 4 times 5 is 20. 1 times 1 is 1. Improper fraction, how many times is 1 going to 20? 20 times. There's our answer. 20 with the equation, when we solve it with an equation. 20 when we do it as a visual. So let me get a different color and we'll do the next problem. Which one did we do? 3 divided by 1/2. Okay. We have 3 divided by 1/2. So I'm going to draw my visual. 1, 2, 3. Okay. How many halves do I have? 1, 2, 3, 4, 5, 6. 6 halves. Halves. Sorry, 6 halves. I had a brain fart for a second. It is halves. H-A-L-V-E-S, halves. 6 halves. Okay. Sorry about that. Your teacher is not perfect, right? I know people who are going to call me out on that, but that's fine. Okay, equation. So I have 3. So remember what I said. Hold on, let me do my division symbol. We have to make this over 1 as an improper fraction. Okay? We're going to change our operation. 3 over 1 stays the same. We need to find the reciprocal of 1/2, which is going to be 2 over 1. All right. Flip. Okay. 3 times 2, 6 over 1. How many times does 1 go into 6? 6 whole times. There you go. 6, 6. Now we have one more to do. Let's see. It's my We can. Do we have room? We have room. We can do it. We can do it. Okay. I'll do purple. We have 6 divided by 1/3. Okay. So I'll do my circles to save room. 1, 2, 3, 4, 5, 6 into thirds. Okay. How many thirds are in 6 wholes? 3, 6, 9, 12, 15, 18 thirds. Okay. Now if we do our equation, we have to make our whole number. Can you see this? Yes. We have to make our whole number into an improper fraction. So 6/1 divided by 1/3. I need to find the reciprocal of 1/3. Bring down 6/1. Change my operation to multiplication. Then move this here. Find the reciprocal, which is we're flipping this to 3/1. 6 times 3. So sorry, that's so tiny. Hopefully you're following along. 6 times 3 is 18. 18/1. It's an improper fraction. How many times is 1 going to 18? 18 whole lovely times. 18 thirds. There you go. There you have it. Dividing fractions with a whole number. I think we have a good platform for today in understanding dividing fractions visually and then with the equation. And like I've always said, I don't care how you solve your math problems, as long as whichever strategy that you use is used correctly and you get it correct, right? So if you want to use visuals for dividing fractions, I'm fine with that, as long as you do it correctly. If you want to just do it the strategy with the equation, I'm fine with that too, as long as you're doing it correctly. Whatever you are most comfortable with, I'm game. It's up to you. Okay, so I think we did a lot today, especially since it's something new that we learned. I want you to remember the relationship that multiplication and division have, where if you do the opposite, you can always check your work. But we can do that tomorrow. We can look into that tomorrow. But that's it for today. I hope you are coming out of this learning something new, and your beautiful light bulbs went off, and your neurons are just going crazy. All right. See you guys tomorrow.